Today, we'll be going over a Google interview question. The question is, suppose we have n cargoes in a queue that we want to ship from one location to another location. Find the minimum ship capacity we need to deliver all cargoes in 5 days.
I usually start with giving you guys some examples, but the question is quite vague, so let's start with some clarifying question. How do we know the weights of each cargo? It will be given to you in an array, so an array of integer, in this case. Can we ship cargoes in any order? Cargoes in the queue have to be shipped in a FIFO manner. So first in, first out. How long each trip takes? Round trip takes 1 day for a ship. So we have 5 days, so we can have 5 trips in total. Now we have more information about the question. Let's go over some examples. Let's say we have cargoes in the queue with the following weights. This is the first cargo, and this is the last cargo in the queue, and each number represent their weights. We have 5 days, and each round trip takes 1 day. So we need to group these cargoes into 5 or less groups in order to ship everything within 5 days. There are many different ways to group them, but I came up with the following 2 partitions. For the first partition, I grouped the first 5 together, 6 and 7 together, 8 by itself, and so on. With this particular partition, we would need a ship with minimum capacity of 15 to deliver all groups from one place to the other. This particular number, the minimum capacity, can be calculated by finding the group that has the highest total weights. In this case, this is that group. The second partition is really similar to the first one, but it groups 9 and 10 together. In this case, 9 and 10 yields the highest total weight, so we would need a ship with minimum capacity of 19 to deliver all groups from one place to the other. If you try out all different combinations, you will realize that the minimum capacity to deliver all cargoes would be actually 15. Let me give you a simpler example. Let's say we have only 5 cargoes in the queue with the following weights. 1, 2, 3, 4, 5. Since we have 5 days to deliver 5 cargoes, and each round trip takes 1 day, we can simply ship 1 cargo at a time. So the minimum capacity will simply be the biggest weight of the given cargoes. So 5 in this case. What would be the most efficient way to handle this? As a brute force approach, we can try all possible combinations of cargoes that we can deliver in 5 days. Would there be any other approach? By the way, I would highly suggest you to code up the brute force approach. It will be a great practice. Coming up with all possible combinations is not trivial, and sometimes, if you cannot come up with an optimal solution, you need to at least show them you can code the brute force approach. If I were to tackle this question, I would use some sort of customized binary search algorithm. Let me illustrate my idea. Let's say you're given 10 cargoes in the queue, similar to the example that we went over together. I will start by adding up all the weights of the given cargo. In this case, it will be 55. Then I will use the sum to run a binary search. Initially, I will set left as 0 and right equals to sum. By the way, binary search is all about having left and right pointer and trying to reduce the remaining possibility by half. So in this case, I'll start by finding the middle point, which is 27, and see if we can ship all the cargoes with a minimum capacity of 27 within 5 days. In this case, it is possible. On your own time, you can calculate this as well. So I will move my right point to here. So getting rid of all these possibility here. And I will iterate the same process. So if you find the midpoint again, it's 13 this time. And 13, the capacity 13 is not enough to ship all these cargoes within 5 days. So you would actually move your left point here and get rid of all these possible capacity. Then you will iterate this process until your left and right point is different by 1 or less. And you'll figure out that the minimum capacity you need to ship all these cargoes is 15. Let's look at another example. First, you would have to find the sum of all weights. In this case, it will be 40, and use the binary search algorithm again. So 0 to 40, and this is our initial right point, and this is our left pointer. Find the midpoint, which is 20. 20 is actually enough to ship all these cargoes within 5 days. So we move our pointer to the right and iterate the same process, and you will end up with getting 11 as your minimum capacity. So in this case, the grouping will be this, 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 and this. 5 groups. Before using this algorithm, make sure you ask your interviewer that it is safe to assume the weight of each cargo is relatively small and the accumulated sum fits in the memory. And this algorithm would yield the time complexity of order of n log of the sum. And sum is this sum. Because we would try order of log sum, different capacity, worst case. And each capacity we choose, it takes order of n to see if it can deliver all cargoes in 5 days. The space complexity would be simply order of 1 constant. If you find a way to improve the time complexity or any other algorithm, a better suggestion, please leave a comment below. I would be really happy to discuss.
All right, let's dive into coding. We need to implement the function that returns the minimum capacity required to ship the given list of cargoes within 5 days. Let's create a function called findMinimumCapacity that accepts integer array of weights as an input parameter. In order to use the binary search algorithm, we need 2 variables, typically named as left and right, to keep track of the range of remaining possibilities. So here's our variables. We'll set left as 0 and right as the sum of all the given weights. We would also need a variable to keep track of the minimum capacity found so far while running the binary search algorithms. Here is our binary search algorithm. As typical binary search, we would start each iteration by calculating the middle point by summing up the left and right variables and dividing it by 2. This middle point becomes the capacity to assess in each iteration. With this capacity, we need to see if it can ship all the given cargoes within 5 days. Ship in 5 days is a helper function that determines whether it is possible to ship all the given weights with the given capacity or not. Within 5 days. The implementation of this is pretty straightforward. If you want to see how it is actually implemented, please visit the link I provided in the description to see the full solution. It should look something like this. And let me know if you have any questions on this, because I can't discuss more, or comment below. Going back to our main flow, there are 2 possible cases here. If we can ship all cargoes with the capacity, we discard all capacities bigger than the current capacity by updating the right variable and record the new minimum capacity we found. Otherwise, we discard all capacities smaller than the current capacity by updating the left variables and continue the iteration. When the difference between the right and left variables is equal or less than 1, we would have explored all required possibilities to find the minimum capacity to ship all cargoes within 5 days. And you simply return the minimum capacity here. All right, we're done. I try my best to come up with a neat and optimal solution for this question, but if you think you have a better way or any suggestions to improve this algorithm, please leave a comment below and I'll happy to discuss. See you in the next video.